Hello and welcome to Unapologetically Technical. My name is Janderson, and this is the show is different. We go all the way down. We have today Kenny Gorman. He is the head streaming products at MongoDB. Welcome to the show. Would you mind introducing yourself a bit more?
Yep. Hello, my name's Kenny Gorman. Like you said, I'm head of streaming products from MongoDB. Been working with data and streaming systems for a long time, almost 30 years. And excited to chat and talk a little bit more.
Good. Well, welcome once again. You didn't mention that we've known each other a while, and I've been wanting this, and I just a lot on the show or known this person for a while, but you don't get that chance to really get to know them and really, what did you do 20 years ago? What did you do 30 years? Usually we're at a conference talking about what's here and now.
That's right. Yeah, awesome. Yeah, I think we met a bunch of years ago when we were starting a podcast for Eventador around Kafka and Flink and streaming, and we chatted back then quite a bit. And I think that's where we started getting to know each other a little bit better. Yeah, good times.
Well, one thing I noticed on your LinkedIn profile is you don't list your education. Are you self-taught?
Yeah, it's an interesting thing. I don't know. Back then, I'm 54 now, so this was in my 20s. I was doing computer-aided design and some data cataloging and database work way back then with things like Sybase. And I had a good job, and I did that while I was in high school. And I got to this point where I was thinking, college was expensive. I went to, I did classes. I just didn't do very well because I was interested in other things. I wasn't interested in algebra. I was interested in how to make databases fast or how to display data in different ways or whatever. And I made the decision mostly because of cost, and the ability to have good grades was tough. And so I ended up not finishing college. And so, I ended up just going self-taught from there. It's interesting now because that value prop has changed quite a bit, I think, in many ways, especially most recently, even with AI. So it's interesting. Maybe I made a bad move, or maybe I made a wise move. I'll never know, I guess, exactly. But that's exactly right. I dropped out. Kind of my first year, I was going to University of Colorado at Denver, and just decided to focus on my career and the things that I was building, and I went from there.
That's interesting because that's my background as well. I've written about it a bit, but I didn't go to college at all. And it's a much longer story that maybe I'll tell another day, but same sort of thing, same sort of difficulties. But back then I would say difficult. It was the internet was just new. You couldn't go on Stack Overflow. You had to figure this out. So what advice do you have for self-taught engineers?
It's interesting. I'm going through this right now because I have two kids, and one of them's just about to finish high school, and so we're having conversations in this direction. And obviously, we've hired a lot of young engineers, and through our various companies and stuff. I think college education isn't a bad thing. In many cases, it's an absolute requirement. But if you're a software engineer, boy, do you have choices these days. It depends on what you want to be, how entrepreneurial you want to be, and the value you're getting from school. The risk reward and cost reward balance is something you need to think about. And is 4 years in this, going to college going to accelerate me or decelerate me? And think through it carefully. When I made this decision, it was pretty well established or thought of that it was a bad decision. It would hurt or make your career harder to have a good career overall. I think now that's changed, and so I would just say it's an individual case by case basis. We never required a BS degree in computer science to hire folks. It was all about whether or not that person was the right fit for the company and could accelerate the company. And I think that's the lens that as a hiring person we have used. And so I would encourage folks, if they're in a great program and they're loving it and it feels like that's going to really accelerate them, if they're at Stanford or something, obviously that's great. But if you're not, it doesn't mean that you're not going to have an amazing career. And I love the idea that entrepreneurship is becoming more and more accessible. It's easier to start a company now than ever. And so maybe these software engineers should be thinking entrepreneurially as well, not just like, hey, I'm going to go work at a big company and write Java every day in a cube or something. Your world is so open right now and so amazing. Coming of that kind of starting your career phase, I'd say just go for it. Figure out the risk reward for your particular situation, and then go for it.
We've talked a lot about diversity now, and I think the aspects of diversity is educational diversity, because that will often manifest down into other parts of diversity. But I think a self-taught person gives you a diversity of thought that is unique. Whereas, you and I, coming from the self background, we're not thinking about, oh, I learned this and this is the specific way you do that, and these are the steps to do this. Usually thinking about, okay, well, how would I solve this problem? What's my logic behind it? And I think the both of those are key. That you have this heavy computer science background. I've interviewed on this show people with PhDs in computer science. It's a different route than my route. But to your point, there's no specific right or wrong answer to this. And you're right as well. Entrepreneurship is one of those routes as well.
Yeah, for sure. And I think it matters in the individual's disposition as well. Like, if you're a problem solver, then you're just going to want to solve that problem. And the venue in which you can solve problems with software these days it's everywhere. And there's just so much opportunity. So if you really identify as a software engineer that solves problems, and that's kind of your thinking and your mindset, which I think it should be, then from manufacturing to aerospace to market, every possible market has a need for this kind of thing right now, and has for a while. And so it feels very durable, and it feels like a great line of work. And it just depends on where you want to be there. If you're going to go be in aerospace, you probably, you might want to have a higher degree because of the problem set that it might give you. If you're not, I don't know, making AI, sprinkler timers, which could be an amazing thing, maybe you don't need that as much, and you can just get to market quicker and go for it. So it just depends, I think. Yeah, like to your point.
Yeah, I guess I've had those conversations with my significant other as well, my kids, and the best advice I could give people is, if you're going to go this route, don't forget your fundamentals. Learn those fundamentals well, and then you can go from there. And I would argue in some way, university not teach you those fundamentals well either. Or what talking about is software engineering is solving problem code, but that is not just what is taught at university either. So there's this disconnect that you and us self-taught people, we had to go at problems from day one, and there wasn't this, what's the longest line of, the biggest program you've written, or what have you done? It's always been, I've always had this problem.
Yeah, I think we'll get into it, but I ended up being an Oracle DBA and getting certified. And why did I do that? I did that because that was the thing that my career needed at the moment. But it wasn't like going to college. It was just going through, and to your point, learning the fundamentals of Oracle, being solid in those things. We'll probably get into it, but I'll point out where those things mattered, I think, as we talk further.
Well, good. Well, speaking of that, so you did start out as a DBA. You started out at Match.com, Music Bank, Kanemeyer.
Yeah, Kanemeyer.
And when you talk about it on LinkedIn, you say there was no sleeping. Why weren't you sleeping?
Yeah. Well, it's funny because I started there as like a very junior developer, and I was working they were using ColdFusion at Match.com. And at the time, Match.com was like, it was 20, 25, it was less than 50 people. It was like 25 people. And so everybody kind of had to wear lots of hats, and we had these contract DBAs, and like, I thought they were badass. I looked up at those guys, and I was like, oh my God, I want to be like that one day. And they were just so smart. They had all the answers. They were earning the big cash. They were well revered. They seemed to just, it was the coolest thing ever. And so I was trying to become a DBA, and I wanted to be in their shoes. And I was writing stored procedures for some of the logic. We had ColdFusion with stored procedures. Funny. And I said, like, if I ever can be on call for a shift, I'll do a good job, I promise. And they didn't trust me for a long time. So I didn't sleep much. I studied Oracle books and tried to really show them I knew what I was doing. And then one time, there's two, they were both on vacation. They couldn't cover. So I got the on-call shift for the weekend. And turns out things melted down. And I jumped in and I was able in the middle of the night it was just a missing index thing, like really super common, DBA thing. But and thank God, because it wasn't hard for me to figure out what was going on, and I was able to solve it in just a few minutes. And I was able to be that, that classical DBA on the sev call and say, oh, it's a missing index. I got this. I'm creating it. It's 50% done, 90% done. Okay, we're done. We're restored. And, be that guy. And so they were like, okay, cool. You're a DBA now. So that was like a big jump in my career. I went home and told my wife what happened. I was like, this was the most fun day of my entire life, career-wise. And I said, I think I'm going to become an Oracle DBA. So I'm going to start enrolling in classes and try and get the certification and do all that. But yeah, that was the big transition from ColdFusion and mostly software engineering to database stuff.
That brings back so many memories. Peak DBA, ColdFusion, all memories.
Yeah.
You mentioned just something off using stored procedures with ColdFusion. Why is that? Tell everybody why that's so funny.
Oh yeah, right. I know, right? It's like this was in the 90s, right? So it was a long time ago, but it basically stored procedure logic was pretty well baked and pretty good, and writing logic in ColdFusion was just like this templated system, and so your web pages would just be tons and tons of just like code everywhere, super messy. You were basically mixing domains. You had HTML and ColdFusion scripting, kind of like how PHP is. And so it was a mess. So we ended up just calling like business logic in stored procedures. And so if there was like add a user or something more than just like the UI scripting and things like that, we'd call a key business function in Oracle PL SQL stored procedures. And that was kind of a nightmare, because every time you do something with a stored procedure, you interrupt the database. Like you lock the database, or or you have to like roll out a new version of a schema or whatever. So it's very tightly coupled and kind of a mess. But that was a real common pattern back then, and boy, did we learn a lot. So yeah.
Well, part of what's funny for me is I've been doing flat element on Python. I don't know if you've dealt with that. They use routes, and I don't know if you did it with ColdFusion, but there was a routing mechanism where there was the CF route pattern where you'd basically been on part of the get URL was the page that you wanted it to render, and so you'd always be hitting the same endpoint, just different arguments to that. Is that how you're doing it?
That's right. And funny enough, we'll get to it, but ObjectRocket was written in Flask and Python, so we can talk about that later. But yeah, totally exact same thing. Routes for basic, functionality, and then passing variables back and forth. Yeah, exactly. Inputs and outputs to stored procedures. Exactly.
All right. Too much trips down memory lane. You also talked about your message queue being under you. Why was message queue under you?
Yeah, I mean, I think so that might be jumping forward to Kanemeyer if I'm thinking straight. But yeah, it's like it was like that whole job is funny. Bill Pasker, the founder of WebLogic, that was his company. I actually had gotten laid off from User Bank and was walking home and met someone on the street and got that job that day as a DBA finally. And they were doing a bunch of stuff with Oracle, and they needed someone to kind of unwind what was going on. So they're like, San Francisco Market Street in the 90s, and I was a DBA, so like you could get a job in a minute. And so I went up there to their office, and they had some performance problems, and I was able to unwind those, and they were using it like a queuing system. And so obviously it's like not a perfect fit. And so we were just able to kind of like say, hey, what if we just didn't do this as a message, or we did this as a transaction? And we just worked on some indexes. And to your point, it was like fundamental stuff. It was just, if you're going to use Oracle in that, a relational database is a flexible thing, and you can use it in various different ways. You can normalize or denormalize. You can index in certain different ways. And it's all trade-offs. You're all, deciding, oh, is this going to make a performance trade-off this way or that way or the other? And in this case, they had optimized for convenience, and scale became a problem. So like, probably like a lot of systems. So it was just sort of like, hey, if we're going to do this long term and you're going to get a lot of users, then we're going to need to do a few things different to make sure that it scales and is performant, that kind of thing. At the end of the day, it wasn't super hard stuff, but it was fun. It was a good, really smart people. Everybody that worked there was very, very smart. I was very humbled to even be part of it. And yeah, it was cool.
Still paid DBA just while on Market Street and people throwing on off for you.
Literally, it was like I was walking home and I saw someone I knew and they're like, "You're a DBA, right?" I'm like, yeah, sure." And they're like, "Come upstairs. We got a broken database." I'm like, "Okay." And then so he offered me the job, and I went home to my wife and I said, "Bad news is I got laid off. The good news is I already got a new job on the way home." So Monday morning, I'm going to Kanemeyer to work. She's like, "What is going on?" So it's fun.
Maybe I should be interviewing your wife and so what's it to be around Andy?
Right, exactly.
It also reminds me of this. There's a book uh, proposal that I read and said, no, they don't do this. It was basically that they were going to write a book on how to use a relational database as a message queue. And I no, you really don't do this. I was thinking, why they would want to write a book about this, because that's a total hack. There are better systems for doing this, but actually the public putting their name on and saying, hey, this is a good idea. I was thinking, oh, you don't want to go there.
Yeah, right. Yeah, exactly. Like, if you're gonna write a book, don't do it on something that's gonna not age well or whatever, or be an anti-pattern. Yeah.
Yeah. Yeah, every so often you'll see a blog post and somebody's really proud of it. There's this Yelp one I remember, and they were talking about hacks. I'm like, no. These are hacks. Why are you doing this way? Why are you doing this? It's really terrible that you've architected this.
Right. Like I'm not above hacking things, but it's mostly with the asterisks of like time to market or whatever, or like we'll fix it later because we got to get to market or it won't matter anyway, or something like that. But I don't know, if you're an established engineering department and you're building, infrastructure for large projects, probably not the hacky route. It's probably not the right route.
No, you don't want to go that route. But speaking of your next job, maybe you got that on the street too. It was at PayPal, which was then acquired by eBay. So
Yeah.
Some of those early challenges at eBay.
Yeah, it was super interesting. So it was one of those things where I think I was on AOL Instant Messenger back then. I think that was the Slack of the day, and I was talking to someone, and they were at PayPal, a colleague, and they're like, "Yeah, our databases are just totally on fire, and we need a DBA. Do you want to work here?" And I was like, and back then it was not clear that PayPal was going to be like really successful or anything. When I moved there, they were at their Palo Alto office, or when I started there, they were at their Palo Alto office. It was like 50 people. They had the company meetings in the parking lot because it's like nice weather in Palo Alto, and like they couldn't fit everybody in the building or whatever. There's no room. And so yeah, it was pretty early on. It was an amazing time. The people there, I mean, as we know now, like the PayPal mafia, like we know who all the people are from that endeavor, and all the things they've gone on to build from. You mentioned Yelp, and lots of different things. So the caliber of people I was working with was a stepwise, it was like 5 order of magnitudes more smart. It was like crazy. And I was very, very humbled. I was just like their QA DBA. Like I just was got like all the like kind of like low level, not important stuff. But that, I was there for 6 years. We got acquired by eBay. Crazy growth. I'd never seen databases, and frankly, Oracle and Veritas and Sun, the predominant platform that we were running on, those vendors hadn't seen databases that were running like this hot, right? So it was like we'd have an E4500, if everybody remembers, like these old computers now at this point, but it was running at a load average of like 50, like all day, all night. And so just like, okay, there's like any computer we got was just burning down all the time. And so there was just it was a target-rich environment for a young DBA to just like go make a difference. And I started off doing big Rsync jobs to replicate databases from A to B, so we could run reports and things like that. So we have like a clone, an offline clone. Got really good at EMC BCV splits and Rsync jobs that were like, we actually introduced a parameter to Rsync. If you search for it, it's called in place, -- in place. So you actually write the file in place. You don't rewrite a dot file and then move it, because we couldn't get the throughput we needed. So the folks that were working on the project actually put that in there for us. Like everything we did seemed to be just like on the hardest side of everything, just because of the workload. And I think, two things that came out of there is, one, it was like the biggest technical thing that I had done in my career at that point I did there. And I also met my co-founder I didn't know and I'd still be working with today there as well. So the story there is that Eric Beebe, my co-founder of a couple different companies, we'll get into that, I'm sure. He was in the NOC with me, and he was a systems administrator and network engineer, and I was the DBA. And there's a whole group of people we met there that are still to this day like good colleagues and investors and friends and everything. But we were in the NOC, and like back then the NOCs were like, I don't know, like NASA. There was big screens, and you were sitting at an elevated desk, and I was on the DBA, on-call rotation. I was sitting there, and if something came up, I'd fix it. And like it's a real deal, like DBA stuff. And back then, if eBay went down, like a CNN news truck showed up, like it was a big deal. And so it was a high pressure environment. It was at the time the hardest work I'd ever done, but also like mega rewarding. We started working on this project I think from a technical perspective, this is interesting. We started to work on this project where we couldn't figure out how to, like, what's the next movement to make a payment, like from a hardware and infrastructure perspective. And a PayPal payment roughly equated to an insert into a database. It was just an insert. And so, we engineered that insert as best we could. We made sure that the tables themselves were as narrow as possible. The number of buffers we were using to write that row was as small as possible. We partitioned the buffer cache crazy and did all sorts of things there. So like we didn't want inserts or payments to make the user flow slow, if that makes sense. So like we couldn't push user records out of cache. So we made a user database. We split certain things off. We did all sorts of like different things. We used reverse key indexes for the first time in my career, where a reverse key index made sense because the ID of the payment was monotonically increasing, and we couldn't really change that easily. And so I made a hotspot on the buffers at the end of the B tree. So what we did was we used a reverse key that really helped. That was like a 2x performance. So that was a big win, just one index change. So it was like a core DBA moment where you're like, yeah, I earned my keep today. But we ended up creating this thing called the PIT test, the PayPal insert test. And it was pretty Neanderthal. It was written in Perl. And all it did was fork off a whole bunch of processes that did fake payments. And it wasn't super complicated. It was just, it just launched a bunch of different Perl processes that used DBI. Was stretching my memory now, and did inserts into the database just like the payment system would. And we could alter the level of concurrency. We could alter the, how fast it would do it, and we just get benchmarks. And it was simple, and that was kind of the key. It was a simple test. And so we noticed that like the older hardware, like the E4500s, were faster than the E10Ks. And so that was a big problem. It was like, why is an insert into a smaller machine slower than a bigger machine? And come to find out that we were pushing that's not the right term. There was contention for the test set mechanism for the memory controllers for the boards in a distributed cabinet and a distributed machine. So Sun E10Ks have modules. They have a memory connector between them, and a local memory is faster than a remote memory fetch. And so literally in Oracle, our inserts were getting so hot that we were like blowing that interface up. So when we missed and we went to a remote memory controller in these big architectures, it became really slow. And it took us a few months to figure out what was going on, but the implication was huge. And that is we can't scale payments, like we're screwed. And there's a few lines of Perl prove that, which was super awesome. So we ended up going to Fujitsu because their architecture was different. And their architecture, I went to their labs and did the test there, and it was crazy. And we ended up, we showed that we could actually scale to enough effect to make the business successful. It was not a perfect scaling algorithm, but it was better than where we were at with Sun at the time. And yeah, so we ended up buying Fujitsu machines and moving everything over, and it was like a huge project. And kind of once we got done with that, I was like, whew, that's enough for me. I'm gonna move on to a new gig. But yeah, it was super, really cool understanding the database stack from the business problem all the way down to like how the hardware, like very, very low level, affected things, and the impact, the business impact of being good at database engineering was super fun. Yeah.
You hit one of my, I guess, laws, or what you say is the more time you spend on something, it's an inverted amount. So the time you spend on something trying to figure it out as debugging, shooting, the smaller the actual thing is. And in this case, it sounds like it was down to a physically small.
Yeah. It was weird because nobody believed it. Like, it was sort of like we had the vendor rewrite the test in C because they're like, it's obviously Perl couldn't be used for this. It's too stupid. But I chuckled because Perl's awesome, whatever. But it was like we had to work through a vendor kind of disbelief situation too, and because they hadn't seen this problem, and so they were like, no, you guys are wrong, of course our hardware scales or whatever. So it was a first time in my career I really had to sit down with vendors and be like, actually, we're not buying this super multi-million-dollar machine because it can't do this thing that we prove in Perl. So it was fun.
Thing, but then it's similar to Python now. It's basically a shim. It's a shim, goes straight into some C code, and that's what we're doing. Everything just becomes C code very quickly.
Yeah, that's right. Yeah, actually, and we, funny enough, that was like the last time I did any Perl. It was like Python from there on out. First of all, because it was easier, but also because of just what you said. Yeah, exactly.
Well, there was a thing that kind of admitted offhand I didn't quite understand. You're Rsync, but were you Rsync? So people know what Rsync is. It's a way of feeding files around and which files need to be updated. But what were you syncing around?
Oh yeah. Okay. So this is a good one. So we had to make clones of databases, and when I started there, I was kind of like, the QA DBA or whatever. So I wasn't trusted with the keys to the castle just yet. And so my job, part of my job was to make these clones of databases for read purposes, for like, the accounts receivable or whatever, compliance or whatever it might be. And so we did an awful lot of cloning, believe it or not, back then, because it was just a reliable way to do it. And so the way you do it in Oracle is you put it in backup mode. So you're letting Oracle know to write a little bit more of extra information to the recovery log. You put it in backup mode, and then you can copy the files fuzzy. You can just copy them out from underneath the database, and the database will be able to recover them and bring them all up to the same system change number, and make the database consistent. So you can rsync a database file by file, like the actual data files, into a new position, and then you basically recover it like you're doing a recovery of like an emergency, and then you can open it with a new name, and you open reset logs in Oracle language, and then you become this new database called like the accounts receivable read copy or whatever the business use case was. So we just did a ton of that, and we started off just doing like, we'd have these orchestrator jobs in Perl that would just launch. It would split up the database into logical threads, and you would copy table space by table space, the different files that make up that table space via rsync, and you copy them from A to B. And to do it fast enough, we had to be really good at rsync. So we had to use like a whole bunch of different switches, because rsync's differential. It reads and it knows block by block if it's got the copy done correctly. So that was really important for Oracle. And then we started to scale out of that, and we started to use Veritas snapshots, which is a file system way of doing it. And then down the line, we actually did EMC BCV splits, which is they call it, I think, a business continuity volume or whatever. And that was a way to take a giant disk array and at the array level, copy things over. So you'd have to prepare Oracle in a certain way in backup mode, and then you do BCV split. That was instant. Like that would happen instantaneously because you're basically splitting RAID sets. And so we scaled it that way. So it was like a multi-year journey of starting off with like this file level, rickety hacked together Rsync copies, which it worked. It kept the business running to like this really robust, storage level split. And then ultimately we ended up making like new copies of databases with different schemas and routed the data via the app in different ways to different places and stuff like that to be more sophisticated. But yeah, early days, it was a lot of database, roll up your sleeve, heavy lifting from the DBA work.
Okay. You were talking, maybe some of the early difference that started to see in DBAs from other DBAs. Like there's very two culture groups of DBAs. DBAs who, to put it mildly or bluntly, knew their stuff, and the people who were there and had that title, and you obviously studied and you really got deep into it. And so I find it interesting. Why do you think you got so deep into this? Is it just your nature? Was it was because you were motivated?
Yeah, this is a good question. I remember sitting on the BART train in the Bay Area, riding the BART to and from work every day, just reading Oracle books like novels. And I couldn't get enough. And it was just because I just wanted to be, I had seen where the people that I considered that I looked up to doing amazing things with databases and being revered for it. And I just wanted to be like that, honestly. Like it was kind of a simple thing. I just wanted to be good like that. And by the time I was at eBay, we had 30 plus DBAs on staff, like 30 plus badass, full on, production DBAs, like really, really talented folks. And I was just proud to be part of that group. So for me, it felt like, I started off kind of tinkering with Oracle. I got this break at Match.com to be on-call guy. And then here I was, a few years later, a bunch of years later, running one of the biggest companies in the world and being sitting in that seat and being trusted with the keys to the database castle. So for me, that was a big achievement. And all the studying and all the learning was kind of just because you could feel it in that group of peers. I wanted to be good in that group. I wanted to be the starter, if you will, the starter player. I didn't want to sit on the bench. I wanted to be revered for my opinion or that kind of thing. And because I really respected everybody there.
You also make a point that I've tried to kind of talking about before of what advice do you give children? What advice do I give early on in their career? That is, don't be the smartest person in the room. Not because you don't know what you're doing, but because if you are junior or you're at a company, you're the smartest person in the room. There's nobody else in that room to learn from. This is how we learn. You learn from experience, definitely. You also learn from hearing somebody else in the room, oh yeah, blah, blah, blah. And you're like, oh, I see why they said. It's this heuristic of you starting these things. And I remember engineers over the years that I had similar things of I looked up to, and I thought, oh yeah, I learned a lot from that person. This is don't try to be sometimes people will try to be the smartest person in the room, and they'll go to be the only engineer or the small engineer for maybe perhaps pride or something like that. But that doesn't help you. You're not going to learn as much.
Yeah, that's really true. I spoke about Eric before, and I think the world of him. He was a great a mentor in that way. He was oftentimes the quietest person in the room, but oftentimes had the most correct answer or had the right instinct on something, or just he had read and studied and understood something so well that he had a level of mastery. And so it was like I saw people trusting him and his peers too, to be frank. And I wanted that trust too. And I think that's the thing. If you're an engineering group and you're like trying to be the smartest person in the room and you're always chiming in with, but I know more, that's an easy trap to fall into. We all do, that kind of thing. Ooh, I know the answer, or whatever. But oftentimes, if you just take a step back, and I'm as guilty as any person, and recognize the team and where the team is in their mental state and what they're bringing to the table, oftentimes you end up better off. Not just the company. The company obviously is better off, but you learn from them. To your point, you learn from them and you grow, and now you have that capability the next time these types of things happen. I am 100% a believer of that, and that's a good call out. Yeah, for sure.
Oh, good. So from PayPal, you went to Quigo. Maybe you found that one on AOL Instant Messenger again, and you started seeing ads there. And that was from Oracle. Anything interesting happen at that company?
No, it was an interesting company, good company, great people. I went there because Eric went there, and I also went there because they were using Oracle RAC, and that was the one thing I didn't know how to do. And so they're like, "Hey, we need a DBA, and we're using Oracle RAC, which is the clustering. If you're not familiar, it's the active clustering software for Oracle. This was in like 2007 or 6 or something, so it was quite primitive back then, even. I was like, yeah, I totally want to go do that. Like, that sounds hard. And so went there. I was only there for about a year. They ended up selling the company, and then it was time for me to move on.
Okay. And from there, you moved on to High Fives. Did you go there with Eric as well?
No, this time, this was like downtown SF situation again. A friend of mine was running a Postgres cluster. And they're like, hey, we have like 10 Postgres databases, and we need like 50 because we're having scaling challenges and we're growing so quick, and we're doing the math and like we don't know how to keep up. So I was like, yeah, I'm in for it. Let's do hard things. So I went there. That was super fun. Learned a ton about Postgres. I'm a huge fan. We used Sloaney. If you're not familiar, it's the way to replicate a Postgres database to another one. I don't think it's super popular anymore, but back then it was like what we used. I was able to use a lot of my experience there because we had we were burning our caches up because of these kind of like just this workload we had. If you're not familiar, High Five, with people probably aren't familiar, but it was Facebook for everywhere but the US. And for some amount of time, it was very popular, and then it really faded. But for the time that it was really popular, the growth was out of control. And so if we couldn't keep up with the database demand, then they couldn't do another raise, and the business couldn't run. And so we really were taking a task to make the databases work so the business could succeed. And anyway, the technical challenge there was pretty cool. The thing that mattered was this is a little deep, but we would fetch IDs from the database for things like login, right? So you'd say you'd fetch ID A, B, C, D, F, G. And what turned out that the leading edge was more popular. In other words, more recent IDs were fetched more often than older ones. And the database was written in such a way that those IDs, the recent ones, were actually sparsely populated in blocks across the disk. And so you'd have to do if you asked for 20 IDs, it'd be 20 block fetches. And so the IO, this is back when it wasn't the cloud, right? Like, this is actually like computers in a data center with actual disk drives and a volume manager. And so the goal there was like, let's reduce these block fetches if we can, because you're essentially overfetching. You might fetch an 8K block, but you only need whatever, 10th of that just to service this call. So what we did was we did this thing called PG Reorg, and we just did it systematically across all the databases. And it's a super simple trick. You just basically query the entire collection or database table, then you order it by that key, and then you rewrite it. And it's just a simple, because then everything's block dense at the head at the higher IDs because it's sorted. So it's just a goofy trick to try but it fixed everything. Like it was like just to your point, fundamentals. You didn't have to be fancy. You didn't have to be smarter. You didn't have to rewrite the C code. It was just kind of a brute force, but built on the knowledge of how databases work and how cache contention works and the business pattern of fetching IDs, and like put that all together. And we just use this thing called PG Reorg. It did it in the background. We orchestrated it across all the databases at night or I think for us it was in the day because everything was like overseas in terms of the load. And we just did it systematically, and it would drop the load by 20x or whatever. And over time it would, as data got deleted or mutated, it would kind of get worse, and we'd redo it. And so that was a big win there. And those clusters are huge. I think we had 100 plus Postgres databases all running in concert for a single business purpose. They weren't all clustered, but there was 100 live front end databases. So it was a lot to sprawl to deal with. So that was fun.
Okay, that does sound interesting. From there, you went to Surfly, but instead of as an individual contributor, you went into management. Why'd you have choice?
Yeah, I sort of wanted to move from kind of the DBA role to something else. Like what was like senior DBA, double senior DBA? What was, at what point do you move your career? And some of the folks I'd worked with at eBay were at Shutterfly, folks that I really respected and I consider good friends, and they ended up being investors and such. And they said, hey, you got to come here. We're building we've got cool Oracle problems, but we're trying to figure out what's next, and we need someone to help figure that out. So I interviewed there. It was super cool. It felt like the coolest thing before I left. They gave me the offer in the office, as I walked out. So it wasn't like I waited a week or whatever. They just said, here, take this offer and let us know. And I remember thinking man, if you ever want to hire someone and you really want them to feel appreciated, give them an offer before they leave. They're going to go home and go, oh my God, wow. I think they did that to everybody. I wasn't saying that I'm special or anything. I think when they roundtabled and they knew they wanted a candidate, they acted right away, which I thought was really cool. So yeah, I wanted to go and be in charge of a little bit higher level decision. And yeah, that's what led me to kind of start the whole Mongo journey started that day, I think.
You're exactly right. One of the lessons I think that if anybody's running a team, managed team, just settle about being decisive on hiring. You pretty much know who you want to hire. You don't you want somebody to really feel it. I would go so far as to not just be appreciated, but to be validated technically, because being on the other side of that table, it can be really hard. The no's are being ghosted, and if you're told right away, yes, we want you, that's some validation and vindication for you right there. And you can,
yeah. You come into the picture completely convinced you're at the right place and ready to contribute day one. I didn't know, but in the background, it makes sense. In the background, they had to as soon as I interviewed, this was in-person interviews back then. And as soon as I got done interviewing, that person would peel off and go into a committee and then, et cetera, et cetera. And then they'd have the round table while I was in with the last person. And then they'd make me wait a few minutes while the last person went in and gave a yay or a nay. And the offer was already kind of ready. And they could just decide not to send it or decide to change the numbers a little bit and then give it. And so they had their whole process was teed up around facilitating that, whatever, just-in-time offer or whatever you want to call it. It was awesome.
I'd love this to say again. So you also said that this was your first entree into Mongo. Why was that?
Yeah, so we were, the situation was they had a photo sharing site that was kind of where so Shutterfly is like a photo printing, digital to physical play. So you could take a digital photo, send it to them, and they give you a physical print. A lot of people are familiar with it. It's a really cool product. But you could also store your photos on a photo gallery. And the way they had architected this photo gallery was it was all XML based, and it was all on it was written in C# and it was XML based, and it was backed by Oracle. And the way it worked was they wrote this giant XML blob to Oracle. And then when you wanted to like update the title of your, you know where I'm going with this. When you wanted to update the title with the XML blob, they would fetch the entire blob, like whatever, 10 megs. And then they would like, mutate the title in the XML tags. Like they'd parse it, they'd change it and in the app, and then they'd write it back as a update to Oracle. And so it's like, predictably, it was, first of all, two things were happening. One is it tore up Oracle because there's these giant, fetches and puts, and the cache was toasted, and all the problems you'd think about. And then the next problem was they had to come up with some locking mechanism because the fetches, you couldn't really transactionally protect that change to the XML document. It's not like an update, what's atomic or in a transaction. So they had to figure out that. So there's like this extra locking thing. And so that was done in software. And then like, it's just wasteful. If you wanted to just do a simple operation to the user, they'd wait 7 seconds to change a title or whatever. It was just the user interface. They were starting to ask like the wrong questions, like, how do we make this more async so the user doesn't feel like they're waiting? And it's just like, well, you could do that, but can the business really tolerate like that level of expense for this outcome? Like, should we really be that fancy? So anyway, that was part of my role, was to help unwind that. And I was Oracle guy, right? So I was like predisposed to use Oracle, but we ended up testing out Postgres, MySQL, CouchDB, Mongo. I forget there were some other ones that were in the mix because just the time frame. And the idea was like, do we have to, can we switch to something that's, do we need to pay Oracle? Quite frankly, do we need to pay Oracle licensing fees for this use case for this site? We could do it over here, but for this component, it's not really a core to our business. Can we do something that saves some money and still give the users the experience they want? So, okay. So we ended up, bottom line, we ended up choosing MongoDB. Okay, so it was a big risk because it was MongoDB 1.0. And quite honestly, it barely worked. It didn't really, it locked like it locked the entire collection when you wrote to it. It didn't have any sort of recovery capability. It was a mess. It was literally 1.0. But two things it had going for it was, number one is the place it was coming from was so crappy that performance was guaranteed to be better. And then number two was it had the really nice JSON structure, and it was schemaless in the sense that like this use case, the schema could vary. And when it did, the thing that you added needed an index. And so it was super cool because you could index in MongoDB at the time, still today, on a field that, there's no schema. You just index a field with a name. And if that field comes in, it's going to be indexed. And so you could kind of preempt a potential performance problem ahead of time. So it was those are the couple killer features. And we ended up going to it. We ended up using most of the XMLs, we didn't change it. That was called the payload. That went into MongoDB as GridFS. So we still had this big XML payload. But we took like the title and the date and all the things that could change, and we moved those out into MongoDB, indexed them, and then they were protected they were a single atomic transaction. So you could just say, because we didn't need to do multiple things. We just needed to do one single thing, like update title. And so you didn't need complex transactions. You could just atomically do the update, and then boom. So the app got we did the prototype. The app was it was 900% faster or something. I think there's a prezo I did on it, but it immediately obviously was massively faster. It wasn't because Mongo was necessarily faster. It kind of wasn't. It was that the combination of the JSON database kind of schemaless design, or JSON-like database, I should say, it's obviously BSON. The schemaless design, the ability to index kind of ahead of time, and then this notion we could have a design where some keys were indexed individually, and then there was this giant payload. It just was a natural fit. And I didn't know it at the time, but that changed the trajectory of my entire life, that day when we figured it out from that moment forward, because now I was like a Mongo guy. So here I am, Oracle DBA, all the things I told you. And now I'm working with this 1.0 weird BSON, JSON database that barely works. And I'm the guy, the Mongo guy. I'm oh no, what did I do? Did I ruin my career, or what happened here? So yeah, it was interesting times.
It's point out that what happened at that point in time there was the plus MongoDB people, and they did not mix with the Oracle people. And, that was a religious sport. You could say it still is. But you talked about it changing your life. You went and founded a company called ObjectRocket. Why did you decide to found a company?
Yeah, good question. So the way this unfolded was, so we were working with MongoDB and trying to make it faster. I said it was 1.0. And at the time, Amazon and the cloud hadn't become like the de facto for everything. It was there, but it just wasn't guaranteed databases were going to be on like EC2 nodes or whatever. Like I don't even think SSD disk variants were out yet at the time, if I remember correctly. It was all spinning disk. So what we decided was I started to use this thing called Flash Cache, and it was a Facebook project. And what it did was it combined SSD and spinning disk. And so it was like an L2 cache, and it was just kind of smart. So when you missed your database cache, it would go to this L2 cache and then get serviced by SSD. And we were building our own boxes back then for Shutterfly for a variety of reasons, including like photo storage. And so Flash Cache was cool. It worked great because MongoDB had this single writer lock thing. So it had lots of locks. And what we figured out was, well, most of the time that lock is waiting for I/O. It's like, okay, well, let's just make the I/O really fast, like best we can. Like we're not going to change this more complex CS problem called locks, but we can make the thing the lock is waiting for faster in the near term. So I said, okay, cool. Let's just, figure that out. So I was at Shutterfly. We kind of got this thing to work, and I called Eric just to chat. So I wasn't working with Eric Beebe at the time. I called him just to talk, and he said, I'm using MongoDB too. And I said, yeah, me and some of his other friends were working on this. And I said, we've been working on this, and like it's way faster. Like this is cool. And over the next month or so, Eric, myself, and Chris Lalonde, another person from eBay, decided like, okay, we're going to go build a cloud system based on this, like an enterprise MongoDB cloud SaaS system based on this. And like, we have to go do this. There's no other way. And at the time, my wife was pregnant with my first kid. And she was like, what? You're going to quit your job? And like, are you kidding? And so we just went and raised funds. It wasn't very formal. I wasn't an entrepreneur. I wasn't like a, Silicon Valley prodigy or whatever. I was just, so we go to lunch with people and I'd tell them what we're doing. And I'd say, we're going to do a note. And it's, I think then it was 20K buy-in or whatever. And so I'd go to hamburgers, and every time I came back with hamburgers while we were in Menlo Park, I'd come back with like 3 or 4 checks. And it was just friends and colleagues. And I just kept telling them like, well, we're making Mongo not suck. And it's just, this is awesome. And I can't guarantee your money, but we're going to try. And it's me and Eric and Chris. And I think, most people invest in people and what could happen, not in necessarily the tech. So anyway, we got enough money that my wife was okay with me quitting, and I quit, and it was awesome. My boss was like, I was like, I'm going to quit. And he's like, no, you're not. You're going to stay here. And I'm like, I'm going to quit. He's like, all right, how much money you want though? Can I invest? So he did, and it was awesome. And we spent the next year building ObjectRocket, and it was just the 3 of us. We did a whole bunch of really cool things that I think today are still interesting inventions. This is before MongoDB Atlas had a cloud. We were the first to shard everything. Everything was a shard. So when you bought something from us, it was a chunk of compute, and we had it running. We were paying for it in the background. We had our own data center, our own hardware that we had figured out. And you'd buy that chunk of compute, that little shard, and then we'd assign it to you. So you didn't ever wait for like, oh, building, I'll get back to you when it's done. You got it right then. And the reason that mattered is if you had a cluster of like 3 shards and you wanted another one, we wanted that to be instant. And so you'd say add shard. You just literally click the button, add shard, and boom, and it would start balancing. It was super cool. So I think we got that kind of dialed in early. We figured out, so MongoDB, when you balance back and forth, will tend to fragment and make the storage footprint get higher and higher, just because of just essentially so many, when you're doing a lot of updates, you leave holes in the data, and then it can kind of fragment. And then by rebuilding one of these nodes or a member of these nodes, you kind of compress that logically. And so we actually would automate that. So we built a system automating those. It's like a whole story in and of itself, but that was cool. So we had a number of really cool inventions. And but we were trying to raise our first round, like our whatever Series A, and everybody kept coming back and saying, "Well, Amazon's going to eat your lunch. You know, Amazon, you're not even in the cloud. You guys engineered around a hardware platform. How dumb are you?" And they weren't wrong. It was kind of stupid to build hardware back then because Amazon was just starting to really get crazy popular for database workloads. And so we ended up trying to figure out, well, who's a match for this? Like, who would, if we can't like go raise around because we're not cloud, you know, we're not thinking ahead and be on the cloud, then this is still important. Like, what can we do? And Rackspace was a natural fit. They obviously had, you know, servers and data centers and all that stuff. And at the time, we had figured out how to onboard customers over Direct Connect, AWS Direct Connect. So we put a slave on Direct Connect, we copied data over, and it was like this magical way to show customers our product and bring them over. And Rackspace acquired us, and we went from 3 people to, we went in that first year, we probably went to 25 or 30 people. And the next year it got bigger. It went very, very quick from there. We got a number of very, very large customers early on. We had this, we were in Austin. I moved to Austin, Texas during this because Rackspace is in Texas. We had this giant, we were at Capital Factory in Austin. We had this giant glass window, and we had, it was like, you know, whatever, 15 feet tall and 60 feet wide or whatever. And it was filled with customer cutover plans. Like, it was literally like, okay, this customer, here's how it's going, here's the date, here's who's working on it. And it was so much demand, like we couldn't even keep up. And I remember just standing there looking at this glass wall that had marker all over it, going, oh my God, I guess this is what demand looks like. I'd never seen anything like that. And so it grew crazy for a couple of years, and it was awesome. It was a really, really fun time. The number of mistakes I made as an entrepreneur, as a manager, as a founder is countless. Like, I made all the mistakes, but at the end of the day, we made something pretty cool. So,
yeah. There's a few parts that I really love. One is every time right now I'm trying to do a startup with, and every time I talk to a VC, they're like, well, XYZ company is just going to eat your lunch. And you're like, no, I know all those people, and they're not going to. It doesn't behoove them. They're not a startup. They're not doing that. But probably the biggest one for me is, we were talking before we started recording, that is the episode before this, we had Jacobo Tagliabue, who had his 3 partners that he always founds companies with. You have Chris, and I'm just completely jealous that you found these people. Where can you find the right person to co-found with? It's not a 1 + 1 = 2. 1 + 1 = 4, because you're able to do such incredible things and play off each other and work well together.
Right. And, you know, I completely think that's true. Eric and I's relationship from a founding perspective, you know, obviously goes way back. But you're right. When we would work on a problem, and I am, out of all these people, I'm not the smartest person. I think that's the most interesting thing. I bring to the table tenacity and crazy ideas and belief, and, you know, some, you know, less, you know, I don't know, maybe less valued or maybe less tangible things. I don't know. But, you know, and I surrounded myself with people that are, I think, smarter than me. But then you just got to give it hell. And I think that's the thing that someone would, like, I'd say is, like, if you're going to pick a founder and you're going to find someone, there is a fit thing. Like, are you friends? And does one person, are you yin and yang? Does one person make up where you're weak? You know, that kind of thing. But then there's also, like, you're going to go sit in a startup trench warfare. You're going to be in the worst of the worst, the hardest of the hard, totally gnarly. I made this story a minute ago sound really great, and it was in a lot of ways, but there's a lot of stories I could tell you about how bad it was. And I'll tell you about Eventador in a minute when you ask. But you know, you have to find that person that you can go to war with. And I think that's the thing. When you're down and out, you're not arguing, you're fixing. When things look bad, you know, you're not turned inward on each other or blaming, you're just fixing. There's trust. You trust each other, even when I might say something to Eric's like, that is completely wrong. But he trusts that I'm not a total idiot because we've been through it together and that there's something there, perhaps. And we should maybe discuss it longer or whatever, not dismiss it. And vice versa. Like if Eric says it's true, it's probably true. And I should probably listen to it, even if I'm disagreeing at the moment. So that level of, those are if I could try to characterize some of these things, to me, it's like when things are dark, what is your relationship? That's the real key.
Yeah, if there's one of all the entrepreneurs I've interviewed in this and talking about co-founders or who you're working with, you find out who they are not when the times are good. You find out who they are when the times are bad. And if you have somebody when the times are bad that backs you up, that doesn't backstab you, isn't blaming you for stupid things, or with this crazy hindsight, I told you so, and no, you didn't tell me so. You maybe you thought that, or maybe you're thinking that now, but that sort of thing, it becomes this incredibly terrible, toxic culture that you're stuck to that person. You're married, basically.
That's right. That's right. And it's interesting. We would be at ObjectRocket, and there'd be some critical thing to debate. And we would actually leave the meeting room where, our teams were that we were running and go debate in person, just one-on-one. And the reason for that was we were debating like founders, which is gnarly for a team. Like the team shouldn't hear us, swearing, or they just won't get the context. It sounds like we hate each other. You know what I mean? And we don't. We're up, but it's just super raw. It's like you've been to the edge and you've come back, and your demeanor with each other is different. And so we'd actually have to sometimes check ourselves out of this team meeting or whatever when we disagreed, and then come back and have a plan that didn't like destabilize our entire company or whatever. So that's to your point. It's like when it's dark and you've built that rapport, then that is durable. It scales. Like that can work for you long term. Just got to be careful when you use it or expose it, because not everybody's used to it.
Well, you briefly mentioned your next company, Eventador, which was a pretty different space. Tell me more about Eventador.
Yeah, so we were at ObjectRocket. We had a bunch of these big customers. One of them was Tinder, if you're familiar with that, with the dating app. And what they were trying to achieve was, for their business, I'm recalling this, so it might not be 100% correct, but something like, when we swipe left or right or whatever it is, that we get notified of someone who's like based on location. So I think what they were trying to do is like if someone's in the room or at a party or like has some sort of, here and now aspect to it. It's not just like, I'll meet them later, but you could just meet them right now. Would that be better for the business? And so they were looking at using Kafka, and they wanted to do a message stream. Yeah, I know you're already shaking your head, but it was really glad they did this, because we started to hear Kafka more and more about this time. This was about 2016 at this point. And we started to hear Kafka. And we got really interested in it. And I was burnt out. And, at some point, if you're a founder, your company gets to the point where it kind of doesn't need you. And that's a good thing. Like it just didn't need, it was at level flight. It didn't need like crazy innovation or just, in fact, me being there was disruptive in a lot of ways, like just being inventive or whatever, pushing the boundaries. Actually, at some point, it's in the way. And so I left when my time was up. I think Eric left a week later, and we just took a year to like honestly play with Kafka. That's literally what Kafka and Flink. We played with those things for like a year, trying to figure out what it was all about. And I was just like paying my own paycheck and like we just did nothing like for a year, just screwed around. We had some offices that we were at, and so we set up a Kafka as a service business because that's what we knew how to do. And we were earning some revenue from that, trying to get familiar with it. And we ultimately decided that Flink was the winner, and like Samsa and Storm and all those other things were out there at the time. But we took a look at Flink, and the geek in us was like, oh my God, this is insane. This is the best thing ever. And we just wanted to be part of it. Like I didn't really know, we weren't really plotting some future business thing. We were just saying, this is cool and it's important and it does cool stuff. How can we participate in this ecosystem? Which is, look, that's not good business advice. Like, by the way, like that's not how you're supposed to start companies or whatever. But for us, it was just like, we just wanted to do it. And so I was like, okay. We ended up sort of realizing that the problem with Flink, though, is it's hard to use, especially back then. It was like, you're writing Java code, you better know, and you and I have talked about this before, you better know the primitives of Flink, you better know the primitives of streaming, you better understand late arriving data, and you better understand when is something batch and when it's not, or, just do, exactly once versus at least one. There's so many core streaming primitives that you have to understand in order to make something for the business work right with Flink. And we saw that as like a problem. We're like, well, people use it, but it probably won't emit, at least quickly, good business outcomes. And so we decided let's go build a SQL engine on Flink. Let's take advantage of the ability to run SQL. Let's turn it into an interface that can allow our user to just look at a stream. Because one of the key observations was that Kafka data was opaque. It's in the stream, but like there wasn't like a PL SQL console where you could just look at it, And so it's like people were just like, well, I don't. And by the way, this gets to a point you'll probably make, but we were finding that customers were putting whatever in their topics. Like it was just a mess. It was just data garbage. Like famously, we had one customer who they had an empty array, a missing key, a null value, a 0, maybe more. Those all meant the thing didn't exist to the business. Like terrible, like a mess. We had customers putting, using the same topic for two different logical business streams, and that they were, you've probably seen all this. And so we're like, oh my God. So let's just make a tool that makes, and we didn't really know, like we were thinking about the business use cases like fraud and the obvious ones, but we're like, let's just make this thing work so we can see what's in the database. So we are in the stream. So we made something called SQL Stream Builder, and it was a utility that ran on top of Flink. It was delivered as a SaaS service. You entered in SQL and you could query the stream, you could create windows, you could do all the things that kind of Flink SQL allowed you. We put a really clever front end to it, so you could write JavaScript transforms to help coax that schema that I just talked about that's a mess into SQL, so you could pre-process it so SQL would work. We could debate whether that's gross or awesome, but we did it. And then we ended up going and doing an institutional round based on that technology. Did a seed round here in Austin with Live Oak was the lead on that, and grew that business and ultimately sold it to Cloudera, who still runs it today.
That's a very good story. And but I have to say, on the JavaScript, anytime I hear JavaScript and data, oh God.
Well, it worked because of Nashorn. So we basically were able to use Nashorn to get JavaScript to work in the JVM. So that was like, you would be right calling it a hack. But to be honest, this is the interesting thing about Mongo. And you and I talked off camera a little bit about schemas and such. The problem we had here was, or the assertion we made was, maybe incorrectly, but it's worth debating, is that streaming data inherently had a varied schema. And that's a big statement. And at its face, someone could argue it for sure. But the point there is that, like, in the wild, not in an academic sense, but in the real customer systems that we looked at, schemas might vary message to message at a high velocity. And that was a new thing for us. Like normally you have a database, you have a schema, it's very, all very controlled. With MongoDB, no, it didn't enforce the schema, but your app better. Because if you just throw a new key in the database, it's not indexed or something, your app's going to break. And so, your app better have a schema. You better have a logical schema design. It needs to be indexed. It needs to have all, that kind of thing. But topics and streaming and, distributed log just didn't have that aesthetic to it. And so people were misusing it quite badly. And so part of it was like, we had to educate them, like, that's not how that works. Maybe you want to use a schema. Maybe you want to standardize. But in a lot of cases, our product couldn't get to market if we didn't have some unlock, because they would go POC it and they're like, oh, this doesn't work with our data, and we'd be stuck. So the unlock there was to write this layer where, and honestly, I think out of like, if you took 10 customers, we probably wrote their transform in JavaScript like 9 out of 10 times. Like, we wrote it for them so it would work, just to sell the product. So yeah, it was that kind of thing.
But it's an entrepreneur thing, and so we're gonna lead into MongoDB, but I'll tell a quick story. And it is do a lot of investor meetings. So institutional investor, VC, I talk to them a lot about what's happening, or what do I feel, whatever technology that's out there. And one time they asked me about MongoDB, and they said they were talking streaming and Kafka, and I said, well, MongoDB's offering I know is going to be great because Kenny Gorman is going to be heading that up. And I got the most weird bit from that investor, because they're not used to it's about the people leading these teams and the people behind it. It's not I guess going back to what I was just talking about with the VCs, they think that you can throw money at any team and any problem, and for certain things you can, but some things you just plain can't. And so when you say yes, they have a good person heading that team, or they have the right person heading that team, they just think, oh, you just throw some money at whomever and they go for this thing. They tech the tech, as I put a LinkedIn post out. So yeah, it was weird for somebody to look at me so strangely, me saying, yes, they're going to be successful because they have Kenny Gorman who's done this before. So with that,
I think that's nice to say. I mean, that's nice to say. I think at the end of the day, though, it's because we've basically broken the database a million times. We've broken streams. I mean, we've really made a lot of mistakes. I don't want to point that out. Like, Eventador was hard. Like, it was like we talked about dark times. It was hard figuring that stuff out, and it took a long time with a lot of pressure from VCs and stuff to get a product that made sense to and earn money. And we learned a ton about like what's wrong with the state of affairs. You and I have talked about it a little bit in the past, but like the schema piece is a big deal. I think it's not necessarily solved. I think Mongo isn't solved either. I'm not going to pretend Mongo fixes.
Well, let's save that for after this, and we'll talk more about that. So it's all kind of in one big piece.
You got it.
So now let's start the board part of this. And would you mind diagramming out what is Atlas Stream Processing?
All right. Okay, sure. So let me just tell you a quick background on what it is, and then I'll sketch it. So Atlas Stream Processing is a native MongoDB component that runs on MongoDB Atlas in the cloud. And it allows you to work with streaming data in a first-class way. So it's built on MongoD, the actual Mongo database daemon, although it runs separately. And it uses librd Kafka as at least in the case of Kafka, as the client. And it allows you to manipulate and work with streaming data inside MongoDB, both as a source and a sink. So let me kind of draw that out for you. So typically, like, I'll start at a high level here. Make sure this works. You're going to see my drawing skills kind of be poor. Okay, so this is the Atlas cloud. Oh boy, bad handwriting. Sorry. You'll see. So typically, the way it works is we have some sort of source over here. We'll do the left to right type diagram. And so this might be Kafka. I'll just use a K. But it also might be something like Kinesis, maybe K's for both of those, and some sort of streaming source. And it can also be, and I'll draw this inside Atlas, the change stream of the database. Okay. So if you're not familiar, MongoDB can produce a stream of changes coming from it. So if you insert, update, delete, it will create a record that's a message. and that message can be manipulated with Atlas Stream Processing as well. And then on the right, we'll have the syncs. So you'll have, so it can be another Kafka topic, or it could be an Atlas database. And as you can imagine, we're adding things like S3, things like that. Okay, so we'll have a journey of adding more and more sources and syncs. But yeah, that's the general architecture, and then I'll draw like that. Now, in the middle, I haven't drawn what that is yet. So a connector, a simple connector like the Kafka connector, which is something that's a product that we make at MongoDB, and that's under my team as well. That's been around for a long time, but it's got a lot of moving parts. It's written on Kconnect, and it's not something that's sort of native to MongoDB. In other words, you create a config for it, or if you want to mutate the data, you write a jar. It's very opaque. It's hard to manage. It's been around for a long time. We used it at Eventador in production quite a bit. And customers at MongoDB were asking for a more native, a better way of working with MongoDB data with streams. So Atlas Stream Processing lives in the middle here on Atlas. And I'll just call it ASP. Sorry for you active server pages fans, but this is now Atlas Stream Processing. In here, you can mutate the data just like a stream processor. So we have the ability to use the aggregation framework, the MongoDB Aggregation Framework, to write ag code. And we can do things like Windows. Oh. And it's not writing all of a sudden. Let me see here. Windows, right, there we go. Windows, and aggregations, and then also be able to call out to databases. So if you want to call out to a database, pardon my drawing here. Put this in, this might be low. Oh, come on. I'm having a hard time drawing here. Give me a sec. There we go. If you want to call out and do a lookup against a database, it does that as well. And it's all written in MongoDB aggregation language. So you might create a pipeline, and it's all pipeline. So the way it works, the syntax, and we can do another slide to show this, but the syntax is, I'll write at the bottom here, is you're going to create an array, okay? And that array has stages. And so you'll have a source, and then you'll have some sort of mutation in between, then you have a sync. So this is a typical stream processing pipeline, right? Like this holds up in various different paradigms. But here in each one of these, you could do something like, you could match it, which is like a filter. You could do a window. You could do a lookup. Yeah, there we go, lookup, etc. And then, add more stages as your heart is content. And then that's the definition of the processor. So you're writing a pipeline, you're giving it stages, and you can compose these stages by like mix and matching them, moving their order. You can call SP process on them in the shell, and it'll show you the results, that kind of thing. So it really gives you a good DSL to operate with MongoDB. And the aggregation framework is not new. We didn't invent that for this purpose. It's been around. It's how you do like a group by in MongoDB. It's been around for a decade. So by leveraging that, we made everybody who's a MongoDB database user into a stream processing user like overnight. So if you've done any sort of aggregation or window in MongoDB, tomorrow you can write a stream processor. You just add a source and a sync, and you're off to the races. One more thing to point out here is we have a registry here. Let's start like registry. And that registry holds your source and sync creds. Also does things like creds for external functions, which we support Lambda now for external functions. It support HTTP operator. You can actually call out to microservices. So we're slowly adding a bunch of capabilities here that enrich and make this much better. including at some point we will have the ability to write arbitrary like UDF code inside it as well.
Yeah. Right. Next. So just to reiterate that, there's no JavaScript, no Python here to write your own.
Nope, you write that. Yeah, correct. It's not, you're not writing it in a separate language. You're writing it in the MongoDB aggregation language. That said, we're adding this is external function capability, and you can write a function in like a Lambda function, so Python, JavaScript, whatever it supports, and that can live, say, like, I'll just write it right here. That function can live right here or wherever in your processor. And so if you had like a business function that did something like, I don't know, invalidate a user or whatever, tag something as fraud, whatever use case you might have, you could write a Lambda function that you call out to if a certain condition is true in your pipeline. And then what's cool is all these operators take input from the previous stage and pass output to the next stage. So if that function returns an answer, you've enriched your stream with that answer, for example. Or like in the case of one thing I'm doing is I'll just draw it up here. I'm calling out to HTTP. This pointer is not exactly great. Apologize for that. But where I drew that box at the top here, HTTP. For instance, I'm calling it hasn't refreshed yet. There you go. I'm sorry for my diagram. It calls out to the HTTP endpoint for OpenAI's API, for instance. So you're taking a pipeline of, like, for example, maintenance records from heavy equipment. Texts have written that in English. You want to take that English and find probable causes and problems. You can hit the LLM that's maybe been trained on your machinery and then return the result. And so now the pipeline's enriched downstream with that result. So maybe you have, the maintenance history, maybe that's a lookup from the database, but then the possible potential problems are from the LLM. And then, your entire pipeline's enriched downstream.
So you kind of glossed over it, but this whole lookup that's right here, this is a hard problem. And this is probably one of the reasons why I'd reach for something like a MongoDB, because that lookup or that iteration, whatever you want to call it, or whatever your use case is for this lookup table, is a harder problem. And the reason why you reach for a Flink over Kafka is this exact reason. If you were just doing this, or actually to right here, this matching very simple things, you'd say, you should just use Kafka directly for that, perhaps. Or streams or something like that. It's doing this full flow. That's where you reach for something else. And we need something.
You're 100% correct. And the other thing is, you might choose this. Customers are choosing this because they're already a Mongo first customer. So in a lot of cases, they're already familiar with Mongo. They're moving the data from A to B already, and they want a simplistic way to emit this stream without writing a bunch of code. But you're right, the lookup. So the way it works today, to talk about that a little bit, is you literally look up against another Mongo Atlas database. So you can enrich.
How about whiteboard that out? Let's go into whiteboard 2, because I think it'll make more sense to do the lookup drawn out.
Yeah, so let me see here. So you have a pipeline down here. I'll just draw the pipeline. And you have your source. And you have your sink.
You're not getting high marks from the penmanship, Peter.
Sink. I'm having a hard time making the pencil work. Hold on. And I get battery maybe low. I don't know what's going on here. Okay. Source to sink. And come on, K. There we go. And you have a database that you're looking up against. And you have a stage. You have whatever stages. And then you have this lookup stage. And it's in Mongo syntax. It's typically like a curly brace and then like $sync, and then it tells you the definition. Okay. I'm just giving you shorthand here for this demo. And then that goes out to the Mongo database and it passes some key. So you give it the ID that you're looking upon, and then it returns the value downstream. So the use case here might be like a real simple one is if I get user IDs in my stream and I need to look up their email, then I can look it up in the database. Now, you're really quickly going to go like, boy, I bet you that's slow. And you're not wrong. So this is done every message. So we wanted to make it so that everything we do is done every message. And then we have things in line that allow you to change that behavior. So if you want a slow but correct pipeline, you can have it. But how do you speed it up? Okay, so there's two techniques. One we're doing now and one we're not yet. The first one is you would do a window here. It's supposed to be a window. And that window ahead of it might be, let's say it's a, tumbling window every 5 minutes. So instead of, 1,000 messages a second, every 5 minutes that window tumbles, you do the lookup, and then you return the data. So that's a technique that customers use quite a bit. Now, it doesn't fit every use case. So the other thing we're doing that we plan to do is okay, let's just be clear. Every database has a cache in front of it. Everybody says, why aren't you caching that? Every database has a cache in front of it. It's called its buffer cache. Like in one way or another, a database is caching blocks. And if you're hitting it really hard, it's going to have a cache. The question is are those blocks in memory on the database machine being put there from your job or some other job that needs those buffers, right? Like that's just fundamental first principle database stuff. So in this case, let's call this L1 and L2. In the case of the database, L2 is really L1, right? Because the workloads come in from somewhere else, if this is a shared database. But anyway, we haven't done that L1 cache in this case yet. We have not done this yet. So that's not done yet, but we have plans to go that direction. This part we are doing today, obviously, it's part of the database. And then this part here, the window part, we're doing today because that's part of the pipeline. So that's kind of the story for how to do lookups today and how to essentially join. Yeah. Any questions on that?
Yeah. So if you're doing lookups, there's an ordering issue of how do you keep your data coherent where there's a mutation that's happening, let's say from over here or over there. So how are you keeping, are you chaining these? Are you running this multi-threaded sync?
Great question. So, right, concurrency. So concurrency matters in this, as you point out. Today, okay, I'll tell you, so this is, safe harbor stuff. I'm going to tell you what we're doing today. I'm going to tell you what we're probably doing in the future, but it's all safe harbor, obviously. But just to give you and your listeners like a picture of like where things are going to go. So today, this is single threaded, a single process, a pipeline. So like Flink, you have distributed state, your windows, the checkpoints for these windows can be distributed, right? For us today, they are not. It is just a single process. We have a checkpoint. We can recover your windows. They are stateful. If you've done a computation and like say that computation, say you're doing sum and it's doing a window over an hour and it dies 59 minutes into it, we don't recompute the 59 minutes. We just recompute the remaining one. So we do the right thing there. But it's not distributed state. You cannot run this in a multi-process scenario today. That said, it's really, really fast. It's built on MongoDB. It goes very, very fast. I won't quote performance numbers, but it's for the vast majority of use cases, it works just fine. But what we're doing is we're also adding parallelism from as we call it, a stage level parallelism. So each one of these is a stage. Source is a stage, sync is a stage, everything in the middle is a stage. And then so we might add parallelism. So like today, you can merge into MongoDB in parallel. And you can just give it a degree of parallelism. So merge degree 20, and it'll do 20 parallel writers. What it does to your downstream database with 20 parallel writers, up to you. You have to design whether you want it to hit it that hard or not. And then lookup, we will also, I'm glad you mentioned it, we will add parallelism most likely there as well in a similar way. So if you wanted to have 12-way fetch for IDs, you could do that. Two things that are important to note here is this is at least once, not exactly once in terms of consistency guarantees. We started there. We'll end up potentially being exactly once down the road. But today, that's where the product is. We've been in production for a year. We went GA almost literally a year ago. So yeah, that's kind of the life cycle of where the product's at.
Yeah, and there definitely is a progression. So what you're looking for is you're about this safe harbor, since you're a publicly traded company, you have to say things like that. But now, there's a progression where kind of what you're talking about with being an entrepreneur is you may want a exactly one system, but what you need to do is you need to get an at most one system working really well, and then add that exactly once. And spoiler alert, a lot of people saying that have an exactly one system actually have an exactly one system.
Right. That's so true. It's important to know the context here because we've used Flink. I put food on my table using Flink, right? Like I really love Flink, and it's an amazing piece of software. But understand where it came from and where it's going. It was Stratosphere, University of Berlin, right? Like it's a academic project that is really, really from a stream processing and data perspective, it's very cool. But we needed to solve a little bit different problem here. And so we live for Atlas Stream Processing in a different spot. The spot we live in is let's make a better connector world. So let's make that connectivity and that first-class Mongo experience for the developer work really well. Yeah, I'd love to build Flink, but I can't fund that day one. To your point, like I can't go. There's not 100 customers that are saying, "Hey, I need exactly once for sure. I'll pay for it." There are way more than 100 customers saying, "I want at least once, and I want it to be simple and usable." So that's been our take on where the state of stream processing, if you will. In a lot of ways, ASP is like a hyper connector. In a lot of ways, it's like a mini Flink. Does that make sense? Somewhere in that spectrum is where we live currently.
So, Dick, what you were just talking about, what the customers asking for, why are the customers choosing Atlas streaming over something else? Why not just go directly to Flink, for example?
Yeah. Good question. So I think a couple of reasons. So obviously MongoDB is a wildly successful company. They have a lot of customers on Atlas. And so to be honest, right now, that's a big chunk of who we're talking to. So they're already Atlas customers. They're already Mongo customers. We can be wildly successful in just that pond of fish, if you will. Not that that's where our aspirations stop, but there's a ton of pain, quite frankly, in there. So like, what does that pain look like? Well, number one is some of these use cases are pretty simple, like alarmingly simple. Like, hey, I just want to get my MongoDB data into Snowflake. It's like, okay, well, what's a first-class supported way for MongoDB Atlas and our support teams and our entire go-to-market thing? Like, how can we wrap around that? And for us, it's simple. Like we just say, like, okay, if you have MongoDB and you have Snowflake, a lot of companies these days are doing S3 and then Snowpipe, right? So S3. And ASP allows you to write to S3 as a change stream. And it's basically all of this is wrapped in Atlas Stream Processing. Not the S3 bucket itself, obviously, but the interface to it. And so, and it's with a simple DSL and a simple way of accessing it. It just gives the customer an instant solution. They've got one vendor to deal with, one person to be mad with, one technical support team, that kind of thing. So I don't want to make it sound like the only use cases we do are really simple, but I also don't want to act like there's not like a ton of pain still out there for just basic streaming workflows. So that's just one. There's half a dozen or a dozen of these types of like good use cases where we're seeing traction. It's about 50-50 if you're curious. 50% data coming out of MongoDB, meaning Mongo's the source, and about 50% of data going into MongoDB, which is like the sink. So both avenues.
And I think that's an interesting point that you're making. As much as we think about all our streaming use cases needing to be pretty difficult or pretty technically challenging, there's still a lot of things that is moving data from point A to point B, and not just moving data from point A to point B, but thinking about it operationally. How do I make operationally easy? Or you also pointed out something of the cross-vendor pointing. We talked about that earlier in the episode. If you could have just pointed at one vendor and they would have helped figure it out, but you had to go with vendors, and that's a time-consuming thing, and that's something that's put on the customer to rather than we'll tap.
Right. And I think it's interesting you point out, it's like when you say put on the customer, over the years, it's like become painfully obvious that like a good product takes the pain away from the customer. And this might seem super obvious to your listeners, so bear with me if it does, but I think a lot of products they make it convenient for the product to build and to deploy, but they make it hard for the customer. And so like we have this like ethos where we're trying to like make Atlas Stream Processing as simple as Mongo is. So we could debate whether you like aggregation framework or not, but if you're in that ecosystem, you're used to it. And it's like we want to make it operate that easy and hide these complexities from the user. And I don't mean hide them because they're not smart enough or whatever. They are. It's just we want to hide these complexities because customers don't like. I don't know how you feel about this, but customers don't care about this kind of academic transition between data in motion and data at rest, like, or whatever, however you want to phrase it. They got it, like their boss asked them to do a thing by next quarter that makes, whatever, Mongo right to Snowflake, whatever that might be, whatever use case. They are not academic about how to do that. They just want it to be up. They want it to be fast. They want to meet the business goals. Like it's pretty practical for most of the customers. And I think that if we make them understand, like one of the things we battle with quite transparently right now is network access, network security. Like we have private link and we have VPC peering and we're adding more stuff every day, but like, how do you help the customer traverse these different network topologies and the security context that goes with it, and the internal security person you have to convince at the company to get that access as well, that kind of thing. They've got enough to worry about. And so like, from our perspective, we're trying to make a lot of this stuff really simple and approachable.
I agree with you there. When I work with teams on doing, especially streaming, I always try to do it with a crawl run sort of mentality of some of these things, as much as this is crawling, because you're having to get, credentials, you're having to get OKs. Those things can be time consuming in and of itself. It's not a technically challenging, it's a time challenging thing. So by breaking that up and saying, okay, we're going to get all of this thing talking together, and then we go do a bigger thing, and then we do a bigger thing, that's how you be successful. If you build this thing and you get down to the last minute and you're trying to get this running, that's going to be a problem. The other thing I would tell people is that there's a step function. So there's that you'll hit, and most people won't realize that there's a step function in streaming. There's, we did this thing of moving data from point A to point B. This is a relatively straightforward. What they don't realize that once they get past that, there's a whole step function here of difficulty increase, a complexity increase. And then you get this level and you're dealing with exactly once, and you're dealing with the various problems of streaming that you don't have with batch, for example. Yeah. And this is when people get really messed up. They don't realize that there's a step function. And then when they hit it, and I tell them, you've hit the step function, your team can't actually do this, team isn't ready for this. And then I get this pushback. Oh yeah, we're ready. We're really smart. Well, I'm sorry. I've done this for a long time. They're not ready for this.
Well, I think you brought up a good point. That in that step function, a good example of that is when someone's coming from a database architecture or a batch architecture, and you explain to them Windows, you say, how long do you want me to wait before closing that window? And they're like, why would you have to wait? It's like, well, data doesn't come in always in order. Like that could be late arriving data. Oh, well, what happens when the data is later than the window? It's like, it's not in the window. It's like, oh, well, maybe I shouldn't close that window. Okay, well, then you're never going to get any results. Wait, so like there's this aha moment of like, yeah, streaming has a different paradigm. And so like we've tried to like make really simple controls around our windows, like how long do you wait? If something arrives late after that, it goes to the deal queue so the customers can see, oh, I got, my windows aren't long enough. There's obviously data always coming in late. I made it 1 second, needs to be 5 or something. So like those types of primitives, to your point, are like, that's the steps. And there's a bunch of them like this. You make a great point.
Yeah. Yeah. So the people watching this, if you're a lead, if you're a manager, even on these teams, know this will happen. And when this happens, that's when the team really shows its technical mettle. You're not showing it here. This is time spent. This is dealing with the corporate, and this is dealing with politics usually. And it's, getting your arms wrapped around this. It all changes. And then guess what? There's a step function from there. And
I was going to say it's a journey, not a destination. Yeah, totally.
Yeah. Yeah. And this could be really difficult. And so as you're talking about that focus on simplicity and that sort of thing, perhaps that's another I'll try to make is don't your systems, only your systems as complexity. Go just go a hair of that complexity, because as you get to the next step, that's going to make that system even more complex, and the next step will be even more complex. If you make it super complex here, guess what? It's going to be unusable here.
That's right. Yeah, and everything gets harder. Like monitoring gets harder, debugging gets harder. Like if you're gonna use a streaming system, you need good solid primitives and a good solid platform. Whichever one that may be. But you really need to have the team that understands that like data in motion is different than data at rest. It's a fight. Like I think all the practitioners, like all the folks who are working in this space right now, understand that. Like it's pretty clear that a lot of the products are really geared to making that better. We're no different that way. We want to make it much easier for MongoDB users to use streams of data. I think everybody's kind of barking up the tree because it's a pretty clear pain point. To your point, it's a journey though. It's not like one simple thing, one simple, really cleverly crafted piece of code fixes this problem. It's a paradigm difference, but at its core.
It's a multi-systemic problem, and that's really key. That the problem, as you'll hit it, there'll be a problem here on Snowflake, and there'll be a problem here on MongoDB, and a problem in S3. And when you put them all together, trying to either debug that or try to fix that, it's really, really difficult. And that's part of step functions that you get here.
Yeah.
Cross multi-systemic, super hard. That's where you need really smart people in the room. You need your Erics and your
yeah. Love it. Totally agree with that.
So let's talk about another thing, and that is, so what are you excited about in the roadmap coming up?
Yeah.
Go to 3, please.
I'm on 3. Yeah. So safe harbor and all this. So I don't know if I'm correctly stating that, but yeah, some of this may or may not happen. We're a public company. I can't commit to any of this, but look, MongoDB is pointed, and the industry is pointed in a very much in a direction of AI. And if you take a pipeline, and I'll just draw this at a high level if I can make the pen work. I can't make it work. Come on. I might need to just talk through this. No dice. So I'll just talk to them.
I'll draw you a pipeline. I think where you're going is something like this. How do you read an LLM?
And then draw me here. I'll give you like a prompt, Jesse. Draw me a database also next to the LLM. There you go. And
I had a wild guess. They didn't rag there.
And then Atlas Vector Search. So we have a product in this space as well. Yeah, you got it. So, yep. So yeah, so I think we're this, and just to kind of break down some things here. So I mentioned that this notion of the maintenance application earlier, where a technician is like servicing heavy equipment and they see a problem, and they're not going to enter in like a highly, they might enter it in pretty crufty English, like like one of the examples was like, it's hotter than a jalapeno out here. No wonder this thing's not working. So like that's not a super deterministic type of input text for a processor to work on. And so the LLM and vector search an LLM and a vector search can work great here. So the way we're kind of seeing this go is, so in that kind of use case, you're going to have, obviously some very deterministic data that's coming in, like just regular database data, like the account and the machine ID and that kind of thing. You're also going to have some text that comes in that's maybe freeform. And in that case, MongoDB has like a really good solution. So, basically you can have your medium-term memory or whatever put in as a search index, as a vector search index, or even just a regular search index, but vector search is particularly compelling. You can have then use one of the APIs, like just say OpenAPI or one of the other public APIs, to then process and reason about that input text, and then go use that to search vector search, and maybe you come back with some common fixes that have happened in the past, that kind of thing. So like from a use case perspective, these kind of pipelines where you're mixing probabilistic processing and deterministic processing in the same pipeline is like pretty compelling, because the world's problems aren't all this like lookup key by ID kind of thing. And a processor gets super valuable when I can just say like, okay, the app wrote this English thing, and in our little use case, you write the problem in English, and it's like, yeah, the tractor's broken or the machine's broken. Hydraulic pressure seems high, but I don't know. And then the application starts to say, well, I reasoned about that problem. I went and looked at the memory stored in MongoDB using this sort of RAG application. The results are coming back. Here's the first 3 things to try. Did you try and check the hydraulic fluid level? Did you try this, that, and the other? And then that application is, compared to where we were 5 years ago, that level of business product is so much more compelling and competitive in the marketplace than where we were before. And processing pipelines are like a key piece to that. Like what you've drawn here, like even though we're just basically sketching out the really basic primitive of it, it's a lot different than it was just a few years ago. I remember we used Flink. We did when we were at Eventador, we did a thing that looked up people's locations using Twitter, the Twitter fire hose, when there was a hurricane, and we were trying to reason about like which one of those people might be in danger and need help. I'm forgetting what hurricane it was, Hurricane Harvey, I think. And people were on Twitter saying like, help me, I'm on my roof. And boy, what if we had a RAG application that took that language, scored it based on urgency and danger, pushed it through the pipeline, processed it to maybe looking at the latitude and longitude, and then there was an application that first responders could look at that showed the nearest people to them and who they could help or something. Now I'm just sketching this out, right? Like I'm just from top of my head, but these types of applications are, back when we did it, it was lots of work and it was all manual, lots of Java code. Now I think, you could spend a weekend and have something amazing to demo, perhaps even further with this kind of stuff.
Yeah, I think I'd agree with you. It's fundamentally changed how we did this. We went a lot into this in the last episode of how LLMs completely changed how we interact with human generated data, or even vector search. Vector databases are completely changing things. So let's go to white 4. And normally we don't whiteboard this out and out, but I'm going to just whiteboard this out briefly. And we were kind of talking about this schema list. So I'll draw out some schemes, since you're networking with schemas. We have columns. We have relation database table. We have here. We have nice ordered rows and everything fits into that where there's a specific uh, int and things like that. But we're in schema, it's this nesting sort of thing. And where compared with other time, you have the build is missing. It's here and they have a new build, for example. So the schema. So one of the issues that I have is that there inherently has to be some sort of schema because a program has to read this row to memory in some fashion and reason about it. And so I believe that schemas is more of a kick-can problem where you're kicking the can this difference in scheme between these two over to, let's say, a web app. And now your web application engineer who knows less about data is now trying to reason about and putting if statements in over here in their code. So they've got their code here and they're putting lots of nested if statements on this rather than we have a table here that maybe there's a null there, but we're not having to put a bunch of nested if statements of, is it this type? Is this type? What's your take on that, Ken?
To me, it's always been about, I think the answer is yes. The business needs a schema, like kind of full stop, right? You need to know what a key means to your business. An ID is, an integer, and whatever a username is their, unique username or whatever. The account balance or whatever you're charging them is important. Like you have to know those keys and what they mean to your business. I think the debate has been like, where do we enforce that? I think that debate's still going on. There's the relational database that enforces it along with an application. We had, if you remember back, we had, like EJB architectures where, essentially we'd have that definition and a bean would have its own kind of schema and the database better match it or you're gonna have a big problem. We've had, things like in the streaming sense, we have schema registry and this notion that like you're versioning your schema on a stream of data. We have something like MongoDB that says, I'm giving you tools to manage your schema like $validate, which by the way, you can use in a streaming context too. Within ASP, you can use $validate. So it's just in MongoDB, at least you're not enforcing it in a rigid sense. You're just saying, I'm going to give you tools to manage it. But your business better have a schema or you're not going to know, like if you got two basically account balance keys for a user, you have a problem. So like at a high level, schemas matter. I told you earlier, like that, how I think Kafka exasperates the problem because I think customers, especially early on, just made a mess. And like, because it was like a free for all, they treated it that way. And I told you like, an empty array and a null and everything kind of meant the same thing to the business. So that's really bad practice. That's a mess. I think that's kind of my take on it. I'll point out that one thing we found that I didn't totally expect is that when you start to work with, and now it seems obvious, but I didn't expect it early on, was when you start to work with something like an LLM and you're using more natural language in your work, and you're asking for results, that schema, while formatted in JSON, say, which is common, that schema is not necessarily hard to find. In fact, it can be highly dynamic. It could be dynamic based on the judgment, the reasoning of the LLM. In that case, having a dynamic schema is awesome because you're not necessarily enforcing it right at that point. That said, if you don't know what the keys are that are coming back from an LLM, you don't know how to process them. So I think there's you've got to find, you can tell an LLM, just return this hard schema and it will. But if you just let it be and say, return what makes sense, it might very dynamically change on you message by message. So I think that's the schema, 2 points. Schema management is going to be kind of a next frontier here. It sounds like almost boring, but I think getting good schema tooling, I don't think schema registry fixes it. I don't think MongoDB fixes it. I don't think, obviously, Enterprise Java Beans didn't fix it. So like, where are we going? Just like more of a community note, like where are we going, all of us as a collective here in terms of streaming world and quite frankly, databases. And how does the business schema get reasoned about going forward, because data is sprawling. I think this is where you're going. Data is sprawling more than it did 10 years ago or 20 years ago. There's more systems. You drew the connectors on that last page, all the different things. Data is moving from A to B so fast now that it's so easy for these systems to introduce bugs or inconsistency or lose revenue or whatever it might be, because schemas aren't managed properly.
It also make the point that schemas are kind of covering over your company's or your technical team's inability to communicate well. You could say, well, we have our enterprise Java bean, and that enterprise Java bean model, whatever you want to call it, is in some common code, and everybody uses that common code. Where if you do that, let's say it wouldn't matter whether your data here or here, your common model object and memory data. But most companies can't do that. They can't get that unified model object because they either can't agree on it or there's multiple domains. There's a lot of problems to create domain objects.
Yeah, and it also is a deterministic factor on how fast you can change your business, how fast you can release, how fast you can keep up to date, how fast you can version your software. So if you have a definitive, schema model and you can't change it, you've essentially locked your business into that schema. You can't easily grow and add new products and compete better in your marketplace. So solving this is important. It's important that you're able, and I think that's where everybody's been at, that we went from one extreme to another. We went rigid schemas, hard to change, no schema whatsoever, crazy data, hard to change because now our data is crap. So how do we find that middle ground? I'm not sure it's solved. I think we're all still working on
it. We definitely are. And so as I've talked to you and I looked over even your LinkedIn profile, I noticed that you have a really good knack at getting into things early and identifying either trends or technologies really early. What allows you to do that, and how do you validate those theories?
I think that's not necessarily a good thing always. Being too early is often wrong. Is that Paul Graham said that? I forget, but we were, just honestly, we were too early with SQL Stream Builder. You see that now. You see a Confluent product there. You see a couple other companies doing that. We were just too early with that product. It was very hard to convince people that was useful. Now it's pretty commonplace. So that said, the saying that being early is cool, but it's also a burden to some degree. I think it's just so how do you identify things early? Well, it's that you're typing on computers every day. I'm, one of a team member of a giant, conglomerate of engineers and PMs and marketing people at Mongo building ASP, but I still write demos. I still type code. I still make the product work. Myself and my team, we do a lot of the QA. We're very hands-on. And so, especially as a product person, if you're not, and engineers too, frankly, if you're not building with your own product, you're not understanding your product. I know Eric builds samples and demos. Everybody uses his examples, in the teams, because he builds some of this stuff. I think the savvy engineer will build and use their product, and then they will find the pain points, and they will have kind of these assumptions about what the future looks like because they're experiencing it themselves to some degree. So I think that's if you're just a practitioner doing something, or maybe it's observability or AI is an obvious good example. Don't just talk about it. Open up an editor, start writing some code, start finding out what works and what doesn't. Be confused. It's okay, and solve problems. And then you'll end up going, oh, yeah, clearly we need insert something here to make this better going forward.
Great advice. Well, Kenny, thank you for coming on the show. I've been asking you to do this for a while, but I really do appreciate you coming on and sharing so openly and honestly.
Yeah, me too, Jesse. It was great chatting. Great to catch up again and see you, and really appreciate the opportunity to chat. It was awesome.